try this here. Let's see how this works. Hello, hello, hello. I think we're ready to go here. Is it working? Just give us a few moments to check if the stream is working. Yeah, seems to be okay. Stream is healthy. It's good. All right. So yeah, here we go. We're gonna go ahead and try to solve some to be okay. LeetCode problems again today. Let's see how this goes. The 2 hours, so it's around my time. It's around. We'll do 2 hours. Okay. All right. Okay. Truncate sentence. All right. Sentence is a list of words. I'm not going to read the whole problem. I'm gonna kind of maybe read part of it, but mostly read it to myself. Just go sort of as quick as I can. Not as quick as I can, but quickly. Very, very quickly. Very quickly. All right. Single space and no leading or trailing spaces. Okay. Each of the words only uppercase and lowercase English letters. No punctuation. Okay. For example. All right. Given a sentence integer k, you want to truncate S such that it contains only the first k words. Turn S after truncating. All right. There's like a split. I don't remember how to split in C++. There's a way to do this that's not terrible. Let me see what I can do here. Let's do a string find routine. Let's do something like that. It's going to be kind of an unusual thing. Oops. Something like I'll show in a moment. All right, we're going to do position. It's going to be s.find single space. And we're going to say int position equals 0 or -1, something like that. We'll say 0. All right. So we're going to find this initial space, and we could do it this way. I think this actually should be size t. Something like this kind of works. If I do it like this, right? And then I'm going to say return s.substring. Like position, something like this. It's something like this, not quite right. This is like an off by 1, I think. I think it's subster, not substring. Yeah. And it's going to be a slightly wrong answer because of the, it's an off by 1 error here. Output, how are you? Okay. How about this one? Something like this. I don't remember the subster like parameters. Oh, how are you, contestant? Hello. Okay. I'll look that up. I don't remember the syntax for this. How's the stream health? Check that every few minutes. It's good. Okay. Oops. Yeah, okay. All right. Let's see. Syntax, position, length. Okay. Okay, and yeah. What so find the first one. 0, 1, 2, 3, 4, 5. And then if we length 5, 1, 2, 3, 4, 5, yeah. So oh, that's what's missing. I think that's it. It's close. It's this one. Wrong. Okay. Okay, this is a little bit better. 1, 2, 3, 4. And 4, 3, 2, 1. They're saying that they want K words. But I actually end up with 5 words here. 1, 2, 3, 4. So K is 4, we get here, 3 here, 2 here, and then, well, 4 yeah. Why, what is the position actually? Let's just print that. Let's print that. All right. Where's my output? Wait, what? Where's my, huh? What? What is going on? Wait, what? What in the world? I'm very confused. What the heck? Uh-oh. I am missing something important here. This isn't executing inside at all, which it's supposed to do some of that. Oh, okay. That's subtle, huh? It's not that subtle, but it's... Well, that'll make a difference. That'll make a difference. Whoops. Okay. Is that better? Okay, there we go. 5, 9, 13, 17. All right. So 5, 9, 13, 17. Huh. Right. So... Oh, but this is... I did this wrong. Okay, hold on. I see the problem. This is a subtle difference. This is a subtle difference. Oh, this is different. This is different. Or this is subtle. Does one extra because the what do they call that? There we go. And it should be one less because of okay. We're just gonna do minus position is less than s dot size, and s of position is space. Something like this. You just subtract that extra. Oh, okay. I guess we're not doing that. Huh. What? Okay. This might also need to be position greater than 0. Just as on the side. This doesn't crash. I should test this on more test cases. Oh man. Oh, that's funny. A, B, C, D. A, B, C, D, E. Let's do 1, 2, 3. Oh gosh, man. Oh boy. Invalid test case. Okay. 1-to-1 only. Excuse me. Okay, I'm gonna go for it. This might be wrong. There's a high chance there's a mistake in here somewhere. Oh, that's right. Okay, that's pretty good. This took me longer than it probably should have. The reason is that the substring, I'm like, I don't remember the syntax for the find and the substring that well. And this also has like, there's potential off by 1 errors here that are not great. I'm sure there's like a better way to do this, faster way to do this. Pretty good memory. All right, that's fine. This is not too complex of a question, so we'll just move on. Not spend too much time explaining. Interesting question though. Definitely an interesting one. Count nodes equal the average of subtree. Okay, roots, number of nodes, the value of the nodes equal the average of the value of the subtree. Oh, interesting. Okay. So the root is equal to its average. Okay, interesting. All right. Yeah, so the easiest way to do this is you calculate the average. You're going to want 2 numbers. You could do a recursive kind of deal. The left subtree, you want the number of nodes and what the average is, and the right subtree, the number of nodes and the averages, and how much, and yeah, the average, and then or just the number of nodes and the sum is probably easier. Let's just see how many values we're dealing with. Yeah, 1,000 by 1,000 is fine. So it'll be most a million. So the left subtree sum and number of nodes, right subtree sum and number of nodes, and then you can calculate this current node, add the 2 sums plus the node for the total sum, and then add the 2 result, what do they call that? Counts, and then add that, and then add 1. And you could propagate, you could use a recursive solution this fairly easily. So we're going to just say const auto recurse. Excuse me. Const auto or recurse. And what we're going to return is going to be a pair, registered pair events. I'm going to return so if, so we're gonna use a null pointer. Target, if target is a null pointer, or not target, then return, we're gonna do number of nodes and the average. So we're gonna say the average is 0 and the number of nodes is 0. I think that's fine. I think that's fine. And then we're gonna say constant left sum, right sum, left total or count, right count. Left sum is going to be RR, curse on left subtree, and that's going to give me, oh yeah, const auto, left P is RR, target left, I think it's just left, right, yeah. Left P, oops, right P. We could do R and L. L sum, R sum might be easier. L count, R count. Right. And then we say the right P is going to be, so the L sum is going to be left P first. Yeah, I mean we could use destructuring here. This might be better. The left sum and left count. The right sum, right count. I don't know if these are good as references, quite frankly. Const references. This does seem better doing it this way though. So L sum plus R sum plus val, and then left count plus right count plus 1. This does seem a little bit better. And then we say target. And what do they want? They want the number of nodes that's equal to the average. Okay, so we're gonna say const double just float, or let's do it this way. Constant check might be better. So it's gonna be total we'll just say sum and sum, current sum, current count. Yeah, it's a little easier. This is a little awkward, but it works. Should work. So current sum is what this is going to be, and on the other side it's going to be current count. And we'll come back to the check in a moment, but I want to have a int result 0 result. Okay. So what we're gonna say is a bunch of and statements. We gotta have the current sum modulo the current count is 0. So the reason why this has got to be this way is these are integers, the values, right? And so the average has to be an integer of average. If it's not an integer average, then there's no way that the value at that node is going to be equal to, oh, excuse me, average is the sum of the element. Oh, never mind. Okay. Never mind. Okay. It's going to be rounded down. Never mind. They're saying it's rounded down. Okay. Never mind. That's a little different. All right. That's fine. That's fine. So it's just going to be current sum divided by current count is equal to, I'm just going to do integer division. Current sum divided by current count is equal to, I don't even really need to check. You can just say result. That's going to be equal to the value. Yeah, if it's rounded down, you can just do integer division. No, must be auto or reference to auto. Oh. Can I do const auto? No. Oh no. Interesting. It looks like I can use const auto. Something like this. Target. Oh, it's not target, it's root. Root. Yeah, this took a while for me to program. I kind of like was finagling with some stuff here. All right, I think I'll just go for it. That's probably it. How's the health of the stream? Okay, it's healthy. All right, that's good. We're 20 minutes going for now. All right. Cool. Accepted. Not bad. Yeah, it's a pretty straightforward kind of what do they call that? Depth first search or recursive algorithm. Call it. I'm surprised it doesn't give me. I'm not that surprised actually. I was gonna say I'm surprised it doesn't give me 0 milliseconds, 100%. But actually, this is a little bit tricky because of because we're using the depth first search. What I could do alternatively, I don't know if it's really that realistic though. There might be a way to do this that's more efficient. I'm just kind of not thinking of it at the moment. Slightly more efficient. Yeah, this is using several milliseconds because it's working through a tree. I mean, I'm not so sure, man. It's also returning a pair each time is a bit awkward. Yeah, it doesn't seem to go much faster than. I'm sure there's a way to do this that's faster, but this is okay, I guess. It's all right. It's all right. We'll move on. That's all right. Another day I'll look into what I can do to make it faster. Some of these I'll probably revisit a lot of these questions. All right. Minimum operations exceed threshold value 1. 0 indexed integer array. Nums, integer k. Remove one occurrence, the smallest element of nums. Turn the minimum number of operations and use that all elements of the array are greater than or equal to k. What is that? Just count the number of elements that are less than k. Let's see if I can do it this way. Let's do nums stood filter. Constant x I mean, there's an easier way to do this. You know, there's actually an easier way. Greater than or equal to k. Yeah. Okay. Isn't this it? Is it that easy? Yeah, I think that's it. I could be wrong, but I think that's it. Yeah. Okay. Pretty straightforward. You just remove all the elements that are smaller, one by one. All right, this looks like it's a JavaScript function. Yeah, more JavaScript. Okay. So, personally, JavaScript's not my strongest language, but that's okay. Function f of n, return a new function that is identical to the original function, except that it ensures f of n is called at most once. Okay. First time the returned function is called, it should return the same result as f of n. Every subsequent time it is called, it should return undefined. So f of n, abc, calls 1, 2, 3. 2, 3, 6. Calls 1, value 6. Find. Okay. Alright. I could try to make this work here. So once function args. So yeah, I mean, I don't know. Let check equal false. JavaScript. Ooh. I mean, it's what do they call that? It's a if check. It's true. Ooh. Not check. False. I'm not really sure actually. I don't know, man. I don't know. That's confusing. Works. I don't know. Something like this. I don't know. Is this true or false? Okay. Oh, that works. All right, I'm gonna go for it. I think that's it. I don't know. Yeah, I mean, you could do don't need an else statement. Yeah, so if not check, set it to true, and then return this once, and then after that. Presumably this works correctly. I'm not entirely sure. All right, moving on. Check stream health. Seems good. It's good. Okay. Number of words found in sentences. Sentences list of words separated by a single space. You're given an array of string sentences. Max the number of words that appear in a single sentence. Okay. Oh, an array of sentences. Okay. All right. So we'll just count the words in each sentence, take the maximum. Okay. So we'll have const auto count words. Takes a sentence. S turns an integer. Yeah. Let's say stood size t position. I think actually this could be inside here. Let's go ahead and do this. Position equals s dot find start position. We're gonna look for actually space. This is not equal to string position. So we're gonna increment the result. And we're actually not gonna modify position. I don't know what this, if this is correct. I'd have to come back to this. So that's the count words, and then we're gonna have a transform reduce because I like it. Using fancy algorithms, fancy schmancy algorithms. So sentences begin, sentences end. We're gonna have 0. We're gonna have stood max, which needs to be a lambda expression. And then there's another lambda expression which transforms. It's just gonna be count words. And there shouldn't be too many. Yeah, it's 100 sentences, so 100 characters each. So not too bad. Transform reduce with the routine account words. Okay, this may or may not work properly. Let's see how this goes. What's up? Hey, bro. What's your LeetCode username? Hello, Satya Mink. Welcome, howdy. It's gonna, oh, TLEs. Whoops. Where is my thing here? Is it? There you go. W plants. Here's my profile. Here's the profile. Here's the profile. Yeah, that's very good. It's very good. It's very good. Yeah, yeah. It's very good. Mr. Polans, Mr. Poland. Oh, TLE. Ooh, that's no bueno. That's not what we want. It's probably TLEing here. What's okay. Let me do something. Oh no, let's do it this way. I need to test this code. That's why. Let's just do count words, like the first word. Let's see out word count. Yeah, writing your own string related functions is always a bit risky. Let's try something like this. Oh, yeah, just test that code, make sure it makes sense, make sure it works. Phew. Still TLE. Jeez. Gosh. All right. So yeah, that's what's TLEing. 1, 2, 3, 4. Wonder why though. Position starts off at 0. Let's just print position. What do we get? TLE. So it's just 5 over and over. Oh, that's, I forgot. I know it's wrong. Got it. Yeah, I forgot that. It's only, I always forget that. Not always, I often forget that. That's a pretty subtle, it's an off by one error. It basically is just gonna, if I'm starting at the position of that initial opening parentheses, then it's gonna I start at that initial parenthesis opening, or rather space. If I start at the space position, then I'm going to end up with, excuse me, 1, 2, 3, 4, and then it goes off. It's a little bit less than it should be. Yeah, I just need to move past the position, the initial space position. I could do -1 initially. That might be easier. Okay. So it's counting one less than it should, though. Unfortunately. It should be 1, 2, 3, 4, and then it jumps off. I mean, you could just also return result +1. I mean, in this case, that's not great code to write. But in this case, it's all given the constraints, I think that works. That's kind of funny. But basically, 1, 2, 3, 4, and the last one, it just assumes. All right, I'm gonna go for it. Just see how it goes. There might be a mistake somewhere. Oh, it's fine. We got it. Okay. Yeah, not my best program there. Not the best way to program that. I could have been done better. It's pretty good though. Overall, it's pretty good. Uses transform, reduce, and simple count words routine. Yeah, okay, not bad. Not great, but not bad. Okay, let's go ahead and let's go to the next one. How are we doing on time? Let me check my stream health. That's what I should be checking. So it's 37 minutes. It's not too bad. Stream is still healthy. That's good. All right. Reverse odd levels of binary tree. Okay. Perfect binary tree. All parent nodes have 2 children. All leaves are on the same level. Interesting. Okay. Level of a node is the number of edges along the path between it and the root. That's an interesting way to define it. All right. Reverse the node values at each odd level of the tree. For example, suppose the node values at level 3 are 2, 1, 4, 7, 11, 2, 9, 18. Then it should become... Oh, wow. Okay, that's unusual. I mean, a BFS works reasonably well here. But like, I guess I'd want the pointers in the BF. Yeah, we could do it that way. That's fine. Yeah, we'll use the tree node pointers in the BFS. It's kind of funny, but yeah, okay, we'll do it that way. We'll go BFS. Should be fine. All right. So we'll do an iteration. And we're gonna say, so we'll use a vector of tree node pointers. And we're gonna say level. We do a level or traversal. Level dot pushback root. And then we're gonna return root, I think. And we're gonna say for each, I guess it's gonna be in the level. And you could do const auto. It's really a tree node. No, it's not gonna be const. It's gonna be tree node pointer in the let's just say node in the level. Also, we'll do, this is another way of doing it too. Or level not empty. Yeah. Gonna do it like this. And we're gonna say stud vector tree node next level. We're gonna say next level dot reserve. It's gonna be level that size bit shifted once. Right, we're gonna double each time. Now we're gonna say node left, node right. We're gonna build the next level. Okay. And then we're gonna say level equals to move. Next level. All right, so this is a level order traversal. What's going to be interesting though is we're going to count. So level count, or which level? Just a level count, or which level? We're going to start off at level 1. Right, so is that right? They said every odd one. So let me see the examples they gave. Is it odd or even? Well, level is the number of edges. Okay, so 0 is the first level. Okay, so it is going to be every second. Okay, fine. Odd depth is sort of this. It's really the second iteration, but all right, that's fine. Whatever. Whatever, man. Whatever, man. Okay, so if which level is if it's 0, then we're gonna say stood reverse level, right? Actually, we want to reverse the values in those. Let's do it this way. There's an easier way. There's another way to do this. We're just going to say vals. We're going to write those values to, yeah, we'll just keep it simple. So we're going to write the values to this values vector. Let's actually do it the other way around. Push the values. And then we're going to say for each tree node, we can do this. Node in the level, say val stop pushback, node value. Okay, now we can reverse and then we're going to say, can I actually reverse the vowels now? Might be easier. Now we can say level of I val equals vowels of I. Something like this. That's a lot more complicated than I thought it was going to be, but that'll work. And then here we increment the It's a level or a traversal, a little more complex code than it needs to be, I think. Whoa. What's up? Hey, bro, it's 3 a.m. my country. I randomly stumbled on your live stream. I don't even know how to code. What's up? With live stream. Hello, howdy, interesting gentlemen. Of them you have privated. What do you mean? I privated a bunch of. You can see how many videos I privated. What does that mean? I may have privated a few things. Yeah. Oh, plus level. What did I do here? Did I got my. Oh, all right. Runtime error. Okay, that's always good. Whoops. Node left. Right. Hmm. How would you know if I privated a video? How would that work? What is going on here? Why would node left be a null pointer? Or no, why would next level be a null pointer? Huh? Member access with a null pointer type. Oh, I know what's wrong. Forgive me, I forgot. That's a mistake. Okay. That's kind of subtle. So basically, I see. Okay. We would just say if node. Yeah, that's actually kind of subtle. I kind of got forgot that a null pointer, like the null pointer, it's still gonna push the null pointers into the vector. It's just, oh no, oh, hmm, hmm. Huh. What is going on here? Oh. Oh yeah, okay. This should I'm a little confused actually. This shouldn't put this shouldn't touch null. Hold on, I'm missing something important here. Pushback root, which level? Level's not empty. You have the next level, reserve. Okay, we're gonna say vectors values. Values, we're gonna push nodes and level. Why would no node be null though? It's not supposed to ever be null. This is supposed to ensure that it doesn't become null. No. Oh, okay. No. I got that wrong too there. I got that wrong as well. There's going to be one level of null pointers that's going to process, which is pretty awkward. I actually I could make it easier and just say, basically, if level like a 0 is a null pointer, just continue, or just yeah. just level that clear. Something like this is probably better, actually. I probably shouldn't do all that extra code. Rockets are... Interesting. I actually like that better than adding all this extra stuff. Yeah. Yeah. Let me... Okay. So level order traversal, but I programmed it incorrectly. Okay. It's always good. That's always good. Good luck, bro. Have a nice day. Oh, shit. 510 videos, but I don't see 500 videos. Ah, there you go. Where do you work at? Where do you live stream programming LeetCode problems? Why do you have a nice day? Okay. I'm sorry. I didn't, currently I'm actually not working as a developer, and I like live streaming coding problems. It's a bit complex. The goal is I was thinking about doing, because I'm pretty good at the like interview like LeetCode style questions. I was thinking about doing coaching, and I figured I probably should just solve all the problems on the site before I do any coaching, or maybe just solve most of them or something like that, because people kind of want coaching, I think. And then yeah, right now I basically work like, I don't know how to explain that. It's not retail, it's the other one. When you work at a restaurant, I forget what this is called. I work at a fast food restaurant. I work at a fast food restaurant. That's the way, yeah. Fast food. I do fast food restaurant work, and then like labor, basic labor, I guess. And yeah, I've always really liked programming. So I used to work as a software developer, but the job market is just like kind of rough. And I kind of just, I don't, it's a bit complex actually. What the issue? It's not so much. I don't like the employers in the job market. That's maybe more accurate. Like I don't like what they want from me. Like they want too much from me, and it's annoying. I don't like it. I think I'd rather start my own company if anything. Excuse me. Although I think, like I said, I think coaching or mentoring or tutoring is probably a better call for a while. And I think about pursuing that. So this is wrong. This is wrong. Okay. I think I misunderstood the question. All right, 3553. Do I get any of these correct? Let's see. No. So this part was not supposed to be touched. 8, 13, 21, 34. Just this part. This 5, 3. Also, the way this is set up, I could probably do this like, well, no. I may not say. I was gonna say I could probably like dump this into an array and then process the array directly, but let me not do that. 530. What did I do? What did I do, man? I reversed the values and then I wrote the values in the level. Level 0 is fine. Oh, no. So in this case, it is, okay, got it. That's the issue. Okay, got it. Made a mistake. Yeah. Yeah, I was getting confused by like how they define the depth of the levels. Like they're saying this is odd, but this is clearly like this was the first iteration, second iteration. Got it. Okay, that's I think the part that's confused about. All right. Yeah, that wasn't the best. That wasn't the best way to do this, I think. I mean, it worked. It's okay. It was okay. It's like kind of slow, kind of wonky, had a lot of issues. Did beat 100% though, which is pretty good. A lot of extra memory it's using. It's a level over traversal, which uses a lot of extra memory. You could do, if you want to reduce the memory, you can use a DFS style that's similar. There's like an extra, I forget what it's called, but it's a form of DFS where like you basically you DFS. How do I explain it? You basically DFS down to the level that you want to operate on, and then you perform your operations on that level. And you do like kind of like each level at a time, but you like DFS down to that level, and then it's a little awkward. I have to double check how it exactly works, but I know it's not that much more expensive if you do it on a tree, even though you're going like repeatedly performing DFS for every level. The reason is that the levels get progressively larger in trees, and so it doesn't actually cost you that much more um, to do it. It's like a geometric thing, and for a binary search anyway. For I think trees with a larger um, trees with a larger branch factor, I think it's a little more punishing to do that. But I forget what it's called. But it's like an iterated DFS, I think. Yeah, I love the word traversal simple enough. I think I kind of psyched myself out a little bit though with this, where I took way too long to program it, and I also like had some issues with the null pointers where I kind of like forgot what I'm supposed to do with those. And this ended up being a little more complex than I think it needed to be. I think it's okay. It's all right. I don't know. I'm not like in love with this solution. It's all right. It's all right. I mean, it beats 100%. You can't do better than beating 100% of solutions, right? Damn, bro, feel you. Hope everything goes well. Thank you. That's all right. No, it's not. I mean, I get bummed out sometimes when I think about stuff, but like a lot of it's my own decisions. Like I don't know. It's weird. Life's weird, dude. It's a weird thing, but a lot of it, yeah. I just don't really like the employers for software development firms. Like, so one of the things I really don't like is that almost all employers, it's like standard across the industry that they want your IP. Like if you write code for somebody, they want the intellectual property to that code, which doesn't seem at first like such a big deal. I'm just gonna check the health of the stream. Doesn't seem like a big deal at first, because you're like, well, that's normal. Like they're gonna write code for them. But then you realize like actually it's a pretty big deal. You could alternatively write your own code, your own company, and your own IP, and it's your own stuff, and then license it. Like you don't have to just give away your intellectual property to other people. But the whole industry is just built on that model. Like the whole industry just assumes that. And like if you ask anyone about it, they're like, yeah, that's how like they just take your IP. And you're like, and I'm sitting here thinking, I'm like, why? Like why do I have to give away my intellectual property just to like pay my bills? Like if I had just written that code for myself and then licensed it to them, I would retain the IP and I'd get paid. It's like, why am I just giving that away to other people? Like, and it's really like they really go hard on like the property part of it. Like they have like all kinds of lawsuits and stuff, and like I think like they're kind of crazy about it. Like they allegedly there was a lawsuit between I think it was like either Apple or it was like these large tech companies. It was like Apple and Samsung or something. These big tech companies, they were fighting over like whether or not the other company could use a rectangle as their phone design. And I was like, this is retarded. Like, this is crazy, man. This is, and it's a similar kind of thing where it's like, why, they go, like I said, they go really, really aggressively with intellectual property, copyright property stuff, intellectual property, patents, that sort of thing. And I'm sitting here thinking, like, I don't like it, man. I don't like it. I don't like having to be like forced to give up that just because like I'm poor, basically. Like I have to do that. Otherwise I can't get a job. And it's like, yeah, but if I just wasn't poor, if I just wasn't poor, then I could start my own company, write the same code I was going to write for my employer, and just license it to them instead of giving it to them, right? Like it's like really, it's kind of horrific actually when you think about it. It's like this doesn't, like, it doesn't jive, man. It doesn't jive with me at all. I think about it, I'm like, I hate this. I don't like it. I don't want to deal with that. I just want to write code, and I don't want to have to deal with lawyers just because I want to write code, and I don't want to like starve just because I want to own my own code. And it's your own thoughts, you know? It's like, why does somebody else get to own my thoughts just because I'm poor? It seems like, I don't know, man. Like, it's, you know, some people might say, well, that's, you're overthinking it. But at the same time, it's like, no, dude, like, it's pretty, like, they take your IP, man. They take it. They just straight up are like, we want this. You're poor. We're taking it. That's how it goes, man. And you're kind of just sitting here like, why? Why? But anyway, that's my rant on IP for a little while there. That's why I struggle with employment. That's one of the reasons. There's a lot of other reasons, but that's one of the big ones where I'm kind of like, I don't like this. I don't want to do that. I don't want to do it. I don't like it. All right. Anyway, so those pandas. Here we go. What do they want? They want so it's somewhat self-inflicted, I should say. Like, I'm not, like, don't feel bad for me. You know, like, I'm not a victim here. I'm just displeased with like the current kind of status quo. And I just don't want to deal with it, you know? I'm like, I don't want to do that. I don't want to. I don't want to. I don't want to. All right. I don't want to give away my IP. I don't want to. I want to keep it. Maybe it's greedy. Maybe it's foolish. Maybe it's selfish. But maybe everyone else is making a big mistake. Right? For each date ID and make name, find the number of distinct lead IDs and distinct partner IDs. Return the result table in any order. The result format is in the following form. Example. Date ID and make name. Okay. Each of those. All right. Find the number of distinct lead IDs and distinct partner IDs. Okay. Interesting. There's no primary key. This table contains duplicates. All right. Interesting. So they give you like a date ID, make name, date ID. So the I find the distinct lead IDs and the distinct partner IDs. They want a table. That's the result output. Unique leads, lead IDs, unique partner IDs. Okay. So let's see if we can figure this out here. So here's Toyota 12.8, 1, 2, 3, 4, 5. So there's Honda and Toyota. These are two different pairs. This is going to have 2 lead IDs and 2 partner IDs. And this one's going to have 2, because the 1 is repeated, and 3. Is that what they have? So for Honda, Toyota, it's 2 and 3. And Honda is 2 and 2. Okay. I mean, sure. All right. There's a few things we need here. So we need, I don't use pandas very much. Oh, it's MySQL. It's not pandas. It's an SQL schema. I could use pandas though. We're gonna use MySQL. All right. I'm a little more familiar with MySQL, with SQL. Written a few queries. So we're going to use the date ID and the make name as like a kind of like a key, a group by maybe. We could do maybe a group by date ID and make name, and then count lead IDs and partner IDs. Something like that. I don't remember what group by does exactly. Let's see. Makes sense. It's how the world works, bro. It sucks anyway. I'm gonna go to sleep. Good luck with everything in life. Thank you. All right, take care, Fennis. I appreciate you come by saying hello. Yeah, I know, dude. I know. It's like it's just how the world works, man. It's how the world works, man. Appreciate you coming by saying hello. Appreciate that. All right. Select. We're just gonna select everything from daily sales, and then we're gonna say group by. I don't know if group by is what I want to use here. I'm just gonna do it though. See what I get. I don't remember what group by does. It just seems like the right thing to do for some reason. And then we're gonna. I don't know. I don't know. What is it? What does this give me? What does this even do? All right, so it compiles, which is good. That's always a good thing. And then my output. Oh, it did. Oh, it kind of worked. Okay. Not really, but all right. Interesting. So we got 1, 2, 3, 4. So I got kind of closer there. I don't know if the order matters. I mean, I could sort by the ID, date ID. All right. Let's do count distinct unique leads or whatever it is. So, let's try that. Count. I'm gonna have to look. All right. So MySQL count distinct group by. Can I do it this way? We'll find out if we do it this way or not. Let's see. The health of the stream while it's loading. Yeah, we're an hour and 7 minutes in. Okay, so I got some questions done. Looks like the stream health is okay. Oh, I can use distinct. Ah, okay. Count distinct. I literally can use count distinct. That's awesome. All right, let's do combine with group by. Oh, that's literally exactly what I want. Wow, that's beautiful. Okay. So we're gonna have date ID, make name, count distinct, lead ID as, let's just put this here as something else. Oh, that's beautiful. That's like exactly what I needed. And what did they say they wanted? Lead ID partner. No. Unique. What do they call it? Unique leads and unique partners. Unique leads and unique partners. Okay, we're just going to move this over a bit so I don't feel so bad about it. Going over multiple lines. Hey, I think that's it. Sweet. That worked. MySQL. I was like, I knew this was not going to be hard. Well, it's an easy one. I mean, it's an easy question. So it's more of a syntax thing. I'll tell you what, SQL syntax is pretty involved. There's a lot of stuff going on there. Yeah, I was gonna say, I think group by you could like one shot that. Okay. Find center of star graph. How are we doing on time? 109. Okay. There's an undirected star graph consisting of n nodes labeled from 1 to n. A star graph is a graph where there is one center node, exactly n-1 edges that connect the center node with every other node. You're given a 2D integer array edges where edges indicates that there is an edge between the nodes UI and UV or VI. Return the center of this given star graph. Undirected star graph. One center node, n-1 edges that connect the center with every other node. Oh, and 2D array of edges. The center? Okay, I mean, I think this one, you just have to find the value that's, I mean, you only have to analyze two things and see which one shows up twice, right? I mean, you can do this at constant time, like super constant time. Okay, we're gonna say const auto or vector edge one. There's always gonna be at least two edges, right? Or one edge. Oh yeah, two edges. Yeah, and there's gonna be at least three. So it's not a unique it's not a unique can I do this? It's not, there's no unique star if so hold on. All right, we're gonna do I'm trying to think of a clever way to do this. Here we go. I got one. Let's do this. Int array of 4. And then we're going to just say array of 0 equals u1 dot 0 1. I was trying to think of a clever way to do this, but I couldn't think of a clever way to do this. Let's just go with this. I couldn't think of it. We're gonna sort it, and now we're gonna say for we're gonna return -1. We're gonna do it like this. For int I0 is less than 4, I say if array of I is equal to array of I plus 1, then return array of I. Not the most clever way to do this, but like reasonable. Yeah. It's constant time. Oh, runtime error. Okay, that's great. What did I do, man? Oh, 0. Oh, okay. That's of course. All right. Hopefully this one shots it. Yeah. Or I should say one shot. This should be pretty straightforward. Yeah, that's like it's pretty kind of an easy one. It's kind of an easy one. Yeah, I mean, I don't know what to say about that. Yeah, I didn't really go over all the things. Oh, this is already solved. I didn't really go over all the details involved there, but basically, the star graph implies that one of those numbers is going to show up twice, looking at two edges, and you just dump all the numbers that you see, sort them, and then the one that shows up twice is just gonna be equal. You can just iterate through them, and the 4 numbers and the one that's the same as the following numbers is the one you want. Integer number n, return the difference between the product of its digits and the sum of its digits. Oh boy. Product of its digits, sum of its digits. Oh boy, oh boy, oh boy. Okay. Let's convert this to a string. So constant string, it's going to be toString. It's probably easiest to convert it to a string. And then now we're going to say return, you ready? It's going to be stood transform reduce. We're going to come back to that one. Minus stood transform reduce. Same thing. And we're going to do s begin, s end, 0, stood plus, and the transform is going to be the following: const char ch return ch minus 0. And this is going to be the product and then the sum. So it's going to be product minus the sum. So this is the sum. This is going to be multiply. Multiply. And this is basically the same thing, except, oops. Doing a little bit of extra work here, repetitive work. This will be a plus. A little bit of repeated work here, but that's okay. And see the chat, we got there. Multiplies maybe. Multiplies. I think that's it. No. Whoops. Oh no. Is it? Wait, what? It's wrong. Oh, this should be. Oh, that's fine. That one multiplies. Start with the 1. Yeah. All right. I think that's correct. Let's try it. Let's see what we get. See how it goes. Yeah, not too bad. All right, next. Deepest leaves sum. Turn the sum of values with deepest leaves. Okay. Okay, so that's not too hard. It's a DFS is fine. Here. Yeah, so you can just do int results. Console auto recurse or DFS easiest. Take the result, return that result. Oops. We're gonna DFS tree node current. And we're gonna say if current left, if not current, and return. Okay, be good to type. If current left is a null pointer, let's just say not. And not current right. Then this is the deepest value. We're going to say result plus equals current value. And then we're going to recurse on R of our current left. And right. Oh, this is wrong, actually. This is wrong. Yeah, this is incorrect. So, okay, let's find, we have to find the deepest first. So actually, this is incorrect. A good first attempt, but incorrect. But fortunately, deepest depth or the deepest. It's going to be deepest. I think the root is what we're going to do. Yeah. Result, DFS. We're gonna have DFS and we're gonna have deepest. So how this is gonna work is deepest. It's not gonna take the result actually. This is gonna DFS with the deepest. And that's actually gonna call what did I call this? Excuse me. It's confusing. All right, the deepest and the result. We're gonna say thing here. Constant depth. The depth is equal to the deepest. Then we do this. Okay. And we recurse on depth plus 1. A little confusing, but yeah. And calculating the deepest is gonna be constant depth. So we're gonna say, actually, I don't need this. It's not really necessary. I could just say left. This is a bit more complex than right. And then just return cinematics of left to right. Okay. And they don't need this. Something like that. Yeah. I think return 0, right? Okay. So we calculate the deepest depth first, and then we use that. So a double depth first search, I think, is what I end up doing here. Explain, please. What's up, XCZXXA? Hope you're doing well. Welcome. Just make sure the live stream is healthy. It is. Compile error. Okay, it's always good. I think I need that here. I actually need to call this DFS too, by the way. Give me 1 second, I'll explain what's going on. I think we start with 0 DFS and root. Give me a second here. I'll explain it. It's compilers. I just forgot to put, okay, submitting too frequently. I just kind of forgot to put the, wrong answer. Okay, so it's good. I'll put 0. All right. What do I get for the deepest here? The deepest. I'll explain what's going on in a moment. Just make sure this is coming out correct. So running 2 DFSs, 1 DFS is going to drop as far down as possible in the tree, and then the second DFS is going to only going to target the nodes that are at that depth. So I got 1, 2, 3, 4. Okay. So the depth at 7 though is not going to be 4. I think this needs to start off at 1. Hopefully the explanation made sense. And it's going to use, there we go. Yeah, it's going to filter on, depths that match in the second DFS. It's going to filter on depths that match the deepest depth that's calculated. There we go. Got it. Pretty good. Pretty reasonable. Yeah, let's see. So there's something here. It's kind of nifty. This is for lambda expressions. If you want to make them recursive, you just pass the parameter here that allows the function to basically continuously pass its own function pointer to itself, or not really function pointer, but lambda, I guess, pointer or something or other. I don't know. I don't know what to call it. Functor or callable, its own callable to itself. Yes, the first recursion is going to say left, and take the depth of the left side, take the depth of the right side, take the maximum of those two, and then add 1 for the root node on top. And then the base case is just going to be when you're looking at an empty node, when you're looking at not a leaf node, but like a child that's empty, or whatever you want to call it, the bottom of the tree that's empty. No pointer. And then that basically will figure out what the deepest depth is if you started with 1 at the top of the root, so 1, 2, 3, 4. Then we save a constant, run another DFS, save, there's going to be a result and a deepest value that we're going to reference. And then now as we traverse the DFS, we're going to keep track of the depth as we go. Similarly, base case, we don't do anything if we're on an empty node. And then when we reach the depth that's equal to the depth we figured out before, we're going to take the current value and add that. And if not, we would skip it. And then we recurse on the left subtree and the right subtree, and then each of those subtrees we add 1 to the depth. So yeah, I have to start off with a 1 for that depth because the way that I calculated the depths, the first node was a 1. So they just need to match these like I guess not the standard, but the I don't know what the right word is for that. The way that I don't know what to call that. Like, however it is that I decided to do that, it just needs to match. And you get random amounts for this in milliseconds. These just need to be consistent. So the first DFS, what's that called? It's not nomenclature. It's not standard. Like whatever I defined as like the initial depth for the root node has to be consistent across both of these DFSs. So hopefully that makes sense. That's a pretty straightforward question, I think. All right, so we're at 125. Okay. All right. Target array in the given order. Given 2 arrays of integers, nums, and index. Your task is to create target array under the following rules. Initially it's empty. Left to right read. Nums indices. Insert index and xi the value nums in the target array. Repeat the previous step until there are no elements to read in nums and index. Return the target array. It's guaranteed insertion operations will be valid. Excuse me. Okay. It might be a good idea to sort the index values so that way I can push things more efficiently. Excuse me. Well, it's only 100, so it's not really that big of a deal. Yeah, interesting. The largest it's going to be is 100. Huh. could just reserve 100 capacity for something. I don't. All right, interesting. Let me do it like this. Let me just get largest or just size, target size. This is a peculiar. I'm gonna name it result instead of target. Max element. I'm gonna say access the index. Yeah. Let's just do this. And then we can just walk through this directly. Is that what? Just run through those operations directly. Runtime error. Okay. Okay. I think it's a +1 there. Wrong answer. Okay. What do they want? I'm confused by this. Okay. Left to right. Read nums and index. Insert at index of I the value nums of I in the target. Repeat the previous step until there are no elements to read in nums and index. Oh, insert. Oh, all right. That's a little bit more. Oh, I see. Okay, got it. Well, I mean, yeah, okay. I see. It's a little different than what I thought. I'm actually not sure about this one. I don't know. I don't really know, man. I'm not sure what I would do here. I don't know if this makes sense. It's kind of like, I don't, how, what? I don't have an insert. Insert vector. Okay, and how's the health of the stream? Still healthy. Position iterator value. Okay. So I need a position iterator. All right. This is confusing. I don't know, man. This is odd. Okay, I guess. It's small enough where this works fine, but it's just very, this is peculiar. I don't know what to say, man. This is odd. This is just an odd question. I don't know. Like, all right, I guess we're doing that. Like, sure. Okay. Anyway. Zero index string word and character. I mean, obviously you could like write your own insertion routine, but it's not that complicated. Zero index string. The reason why I'm questioning, there's like a lot of questions you could say about that. What we just did. It's like it raises a lot of questions. I'm not gonna go into all that, but just LeetCode's fun, man. Zero index string word and a character ch. Reverse the segment of word that starts index 0 and ends at the index. The first occurrence of ch if the character is not exist, the word All right, so this is pretty straightforward. This is pretty straightforward. It's gonna just be like constant size t position is gonna be word find ch, and then we're gonna instead reverse word begin plus yeah word begin plus position, something like this. It's something like this. A little more complex than that, I think. So for case one, we have A, B, C, D, E, F, D, and the output I had C, B, A, D, E, F, D. Yeah, I think I needed to add one more. What is this? Okay. Oops. What if it's not there? If it doesn't exist, do nothing. Okay. So we're just going to say if statement there. If position is not equal to string position. This is correct generally. I'm gonna go for it. I'm not sure if I need that if statement. I'm just gonna throw it in there just in case. All right, pretty good. Not bad. Let's check again. So next question. How much time do I have? Yeah, I'm at 37. Get 21 minutes here. Matches of count of matches in tournament. Given integer n, the number of teams in a tournament that has strange rules. Oh gosh. Okay. Excuse me. Oh yeah, I'm so tired. I've been not getting a lot of sleep lately. The current number of teams is even. Each team gets paired with another team. A total of n over 2 matches are played, and n over 2 teams advance to the next round. If the number of teams is odd, one team randomly advances in the tournament, and the rest gets paired. N minus 1 over 2, n minus 1 over 2 plus 1 advance to the next round. Number of matches played in the tournament until the winner is decided. So this is logarithmic in n. You can just simulate it very directly, so that's fine. So just for n is greater than 0, and we're gonna say plus count. This is how many rounds are executed is what they want. Yeah. Oh, the number of matches. Oh boy. Okay, never mind. Excuse me. Okay. So it's going to be if it's odd, we're going to say n equals n minus 1 bit shift 1, right? And then otherwise, n is bit shift to the right, or yeah, bit shift to the right 1. If it's even, we could just bit shift 1. And then we would say, yeah, I guess we would do matches plus 10. And then this is plus matches. Something like this. Wrong. Okay. 7, I got 7. So I got 6. 15. Interesting. I think it's if n is greater than 1. If there's only one team, then I don't think you play the match. By the way, I'm noticing a slight pattern. I'm going to go for it. This is possibly wrong, but I just kind of went for it. Oh, it's right. Okay. By the way, it looks like I noticed a pattern pretty quickly here. That could just be turn n minus 1. So that might always be true. Let's try some other test cases. This is just a guess. 100, 200, 150, 16, or let's do 64, 28, and maybe, I don't know, 10. Just doing some noticing here. Okay, it looks like it's just n minus 1. I'm going to go for it. It seems consistent. So yeah, there we go. You probably could prove it. That's just n minus 1. I think because each match eliminates exactly one team, and you're eliminating every team until everyone's gone except for one. You gotta be kidding me. Since you're eliminating everyone until you have one team left, that means you're always going to play n minus 1 matches, regardless of the thing going on there, algorithm, whatever the odd. All right, I already solved this one. Let me see if I can quickly get an explanation for the solution. Increase to keep city skyline. N by n blocks. Each block contains a single building shaped like a vertical square prism. 0 indexed n by n integer matrix represents the height of the building located in the block at row R and column C. Okay. Okay, I think I understand. So it's a 2-dimensional array, and then the numbers represent the height of the buildings. Okay, got it. Skyline is the outer contour formed by all the building when viewing the side of the city. So it's like sort of like a 3-dimensional kind of a shape to think about, like grid-based shape. Side from a distance, skyline from each cardinal direction may be different, allowed to increase the height of any number of buildings by any amount. Can be different per building. The height of a 0-height building can also be increased. Increasing the height of a building should not affect the city's skyline from any cardinal direction. Turn the maximum total sum at the height of the buildings can be increased without changing the city's skyline from any cardinal. Yeah, so it's going to be the for each grid position. You look at the values above, left, right, and below, and it's actually not just above, left, right, and below. It's going to be everything all the buildings to the left, all the buildings to the right, all the buildings above, and all the buildings below. The maximum of those are going to define the skyline for the different directions. I think it's actually the entire row or entire column. The maximum defines the point on the skyline for the east and west, and also the north and south, like views. So basically, in order to not modify the skyline, you would need to be smaller than the minimum of those two maximums. Yeah, and so you could take the difference between the current value and the minimum of those two maximums, and that's the total sum of the height of the buildings can be increased without changing the city skyline. So that would be just the sum of all those values. And you can do this pretty efficiently. You can just pre-compute the row and column maximums. And then for each position, you can quickly calculate the minimum of those two values and then the difference between the current value and those two minimums. And that's it. Yeah. And obviously, if it's negative, then you just say 0 for that spot. Take the sum of those. So that even though I solved this, that's like how you could solve this. If you had to do it again. If I had to do it again. All right. So we got another 15 minutes roughly. Total time spent by each employee. Pendas. Here I can use MySQL. So I probably will. They want solution to calculate the total time in minutes spent by each employee on each day at the office. Note that within one day, an employee can enter and leave more than once. The time spent in the office for a single entry is out time minus in time. And the result table at any order. Result for rest of the following table. Excuse me. In time, out time. So you just take the difference between the in times and the out times. It's the sum of it's for all of the employees, right? Each employee on each day. Okay, so in that case, actually, you're gonna want to use a group by. And in fact, you can take if you're taking the difference between the out time minus in time, you can take the sum over the out times minus the sum over the in times. Interestingly, that works. So, okay, so we're going to use a group by and then a function. Select from table group by ID event day. What's the output supposed to look like? Okay, we're going to do event day, employee day. ID. And then we're gonna say select. It's gonna be the sum minus the sum. It's gonna be just. Let's do event day employee ID. Event day. This day. Employee ID. And then it's gonna be the sum of the out time minus sum of in time. As I should put these on multiple lines. What's the total time? I used to work on, just those of you who are curious, I used to work on algorithmic trading systems, electronic trading systems for large hedge for firms that like manage basically for like firms that manage large sums of money, like assets that they have under management. So things like hedge funds and like pension plans and that sort of thing. Yeah, it's pretty straightforward. I mean, this is a pretty straightforward one. Group by is very powerful. So hopefully that doesn't need too much explaining. But yeah, companies used to pay quite a lot to interview me. I don't know. I kind of stopped doing that as much though, I guess. All right. Find the number of good pairs. 1. By the way, like these problems are kind of easy problems, trivial problems. Like they're good to like work your brain, work your mind a little bit, but in actual fact, like the really hard questions are much more challenging, I guess, much more like involved, a lot more thinking, a lot more like sitting and thinking, pondering. A lot of this is a little more routine. Okay, given two integer arrays, nums1 and nums2 of lengths n and m respectively, you're also given a positive integer k. Pair ij is called good if nums1 of I is divisible by nums2 of j times k. J I less than or equal to n minus 1, j less than or equal to n minus 1. Total number of good pairs. N and m respectively, you're also given a positive integer k. Pair is good. Nums of I is divisible by nums2 of j times k. Okay, interesting. All right. 50 by 50. I mean, probably the most straightforward thing to do is just try every pair. I don't know, there might be a more number theoretic way to do this more efficiently, but that's just kind of the first thing. I mean, yeah, there's this one here suggests that they build on this. I mean, the easiest thing to do is just check, like use a filter on nums1. Well, maybe you could do like for if k divides nums1, that's like an early filter you could use. And then the second thing is you could get the divisors of nums1 and then check for those divisors in nums2. I don't know, man. It's a bit of an odd. You know, it might be easier actually to do. Well, you know, I'm not really sure actually. Now I'm really thinking about this. Like, yeah, I don't know. This is an odd question. This is a good one. I don't know. I'm not sure what the faster solutions would do. I'm sure there's interesting things you could do here, but the really straightforward one is just kind of go straight for it. You got x, you got y. And you say just a result. X modulo times k 0, something like this. Okay, live stream is still healthy, which is good. Yeah, I mean, I'm sure there's a better way to do this, more efficient way to do this, but we're gonna go with this for now. Maybe come back to that. Oh, I'm sure I'll see that question later. The variants that are more complex. Convert an array into a 2D array with conditions. Okay, how much time do we have to? I think we got a couple more minutes here. Also, you can't see me anymore. Become invisible. Yeah, I got like 7 more minutes. All right, that's pretty good. Given an integer array nums, you need to create a 2D array from nums satisfying the following conditions. The 2D array should only contain only the elements of the array nums. Each row in the 2D array contains distinct integers. The number of rows in the 2D array should be minimal. Return the resulting array. If there are multiple answers, return any of them. 2D array can have a number of different number of elements in each row. Excuse me. So 1, 3, 4, 1, 2, 3, 1, 1, 3, 2, 4, 1, 3, and 1. We can create a 2D array that contains the following rows. All elements of nums are used. Each row of the 2D array contains distinct. So this is basically a partition. Okay, partition of distinct integers. I mean, you just use a frequency map of the integer that's most present, the highest frequency integer, and that's the size of the array, and then you can just dump. You can just round robin the other integers into those arrays. Oh, nums of I is less than or equal to length. That's pretty good. So you use like a counting sort for this. It can do this very efficiently. Which I think is just, it says 200, right? Yeah. So we're gonna do int, you can do static int. Frequency 200. It should be 201, I think. This is just initialized to empty. We're gonna say for constant x plus frequency of x. Then we're gonna say constant largest stud max. And then we're gonna say vector events. Salt is gonna be, or just empty vectors. And then we're gonna say int I0 is less than 201. Then we're gonna say what for something like this. Result of j dot pushback I. Something like this, I think, works. A bit involved, but I think it does the trick. So how do we do? Yeah. So you take the frequency map, take the largest frequency, create a bunch of distinct sets or distinct vectors that way, and then just round robin the rest of the elements. And this apparently is not the most efficient way to go, but it's reasonable. Yeah, it's good. It's okay. Gets 100%. It's fine. All right. All right. Still got a few minutes here. What does this say? Oh, excuse me. Let me do like one more question. Okay, solve maximum binary. We'll come back to that one, but yeah, integer array nums, no duplicates, maximum binary tree built recursively, following algorithm. Root nodes values the maximum value in nums, recursively build a left subtree and the subarray prefix on the left of the max value, right subtree on the subarray. Yeah, so this you would use a recursive algorithm most likely. I'm not going to go into too much detail like what you'd use, how you use it, but that's probably, it's not too hard, I think. Yeah, and you do sort of like on a range, you do like a recursive algorithm on like the ranges that you end up with. So you'd want to, when you find the maximum value, split the range, and then the left subtree and right subtree become those, the results of those subranges. Subrectangle queries. Implement the class subrectangle queries, which receives a rows, columns, rectangles, a matrix of integers. The constructor supports two methods. Update subrectangle with new value, updates all values, and with new value subrectangle. Upper left coordinates row 1, column 1, right coordinates row 2, column 2, get value. Okay, I mean, sure. 500 operations, rows, columns 1 to 100. Okay. All right. So this is pretty straightforward, I think. Rectangles, rectangle, say private. Stud vector, and and now we're gonna say grid plus rectangle. I mean, I could still move the rectangle. All right. For int r is row 1. Is it including row 2? Yeah, bottom right. Yeah, includes row 2. Okay. 2. We're gonna just say std fill. Grid of r. I'm just gonna call it t. Auto reference t equals grid of r. T begin, t end. Value. And it's gonna be plus column 1 plus column 1 plus column 2. I think column 2 plus 1 rather, actually. All right, it's updating, and then the value just return grid of column. I'm assuming these are not like in out of bounds things. It doesn't say it, so that could be a problem, but we're just gonna assume might be incorrect. That these aren't going to have like out of bounds things going on. They might want you to, yeah, so it's okay. They sometimes will, like, they want you to ask questions about, like out of bounds related things, but, I don't know how to explain that. That is not the most efficient solution as well, which is weird because this is pretty, it's like pretty straightforward. Yeah, I mean, it's fine, I guess. Yeah. All right, I think I'm gonna stop here. So I'm getting really tired. Thank you for watching. This was fun. Let me go turn the light on so you can like see me. Gosh. Hold on just a moment. Yeah, let me turn the light on. Let's get a bit of close this light on. Okay. You can see me now. Okay. Sorry about that. I actually think I'm basically done here though. Like, did okay. I mean, um, yeah. Let's just stop here, I think. So yeah, thank you for watching. It's been fun. If you like the stream, don't forget to like, share, subscribe, comment, all that stuff. I don't know what else to say. Well, thanks for watching. Thanks for watching. All right, I'll stop there.